From here can. Hello? You hear me? Wong, you should respond. Why are you there, not here?
Saya balik kampung sudah. Sorry,
In here?
madam.
It is talking, but we cannot hear.
Oh, we cannot hear you. Are you talking? Yeah, as loud as as if you are here. Can you hear me or not?
Very strange.
Yes, madam.
Okay,
Yeah, somehow I saw you unmute Wong, but we cannot hear you.
Hello. 没有，麦有问题。Hello。Hello.
I wonder if this or not.
Oh, wait,
Oh, it echoes though.
Okay. Let's see wait a while. What? Are you all pula?
I click cancel.
It's not.
Yeah, just now I click cancel.
Hello, can you hear me? Just now can hear. Okay, you off yours.
Okay, now I open the mic.
I close everything.
Okay, so you log in already, is it?
Yeah, I already opened the mic.
You mean you are in here?
Yeah, I'm in there.
Okay.
Rebecca Lai.
All right, can you hear us now? Can.
Okay, I
Okay,
guess
so-
we'll just
So
leave it like
it's
this.
yours.
Is it clear?
Is it clear?
Is it clear?
Yes, the distance is like
Yes. No echo? Very clear. Okay, so we don't know whether it's from here or there, but anyway, it works now.
It works.
So, all right. Okay, now let's share this. Take attendance. Okay. Aduh, susahnya. Half an hour.
Tomorrow boleh online saja lah, madam.
Tomorrow online saja.
Yeah.
Okay. I really need to practice to use the tab again. Don't like to use it, that's why I prefer hybrid. That's the main reason. I am old school.
Yeah.
Okay.
It's not bad.
I mean, I think someone asked for manual attendance.
Oh, just put it in the chat lah. Today should be the last,
Hopefully.
hopefully.
Yeah.
Tomorrow
last section.
just... Have I posted the tutorial ka?
Tutorial 3, yes.
Second order, right?
Yes.
Yeah, okay. So that will be tomorrow. Okay, so we are going to look at the where we left off. So far we have looked at method of reduction of order. That is for the why we have, when you have a repeated roots, how to handle repeated roots for characteristic equation. Then our general solution will have, our general solution will be, can you guys see what I've written here?
Yes, but pixelated.
Pixelated. Oh, kesiannya. So repeated roots, remember we have the general solution is y equals to C1 e to the power of r t plus C2 t e r t. Okay, so the reason why we have this, we use method of reduction of order. Okay, and in fact you can use method of reduction of order for in order to find the second solution. Yeah, so basically method of reduction of order is when you have, you know, one solution and then after that you get the second solution. Yeah. Why you ran here?
Aduh.
Are you okay? Oh my God, you seriously ran. Terselio. Okay. So basically that's method of reduction of order, and then we have looked at method of undetermined coefficients. this is when we have the usual ODE, a second order ODE. Okay, and we have the non-homogeneous part here. Yeah. Before this, we have looked at homogeneous where, so homogeneous is when G is equals to 0, right? So with non-homogeneous is when G is non-zero, okay? And we look at the solution of the homogeneous part to hypothesize or to try for the particular solution. Okay, particular solution is where you consider the non-homogeneous equation. Okay, so general solution for non-homogeneous equation is y equal to y. This is the homogeneous solution plus yp. This is the where you consider the non-homogeneous. Okay, so you need to remember this. So method of undetermined coefficients is when you find the particular solution, yp. Oh, sorry. Am I not supposed to share the screen? Yeah, better, right? To not share. Is it?
You can still see the whiteboard.
Still can see the whiteboard.
Yeah, right now we're seeing the whiteboard and the QR. And now we're seeing the slide and the whiteboard.
Okay, lah. All right, so that is MUC. Then we went through few examples, and we noticed that I think in the last examples where, okay, so for product, you can still do product, okay, product of G of T, okay, so where you need to consider both of them. And then the sum, for sum of the G of T. So say for example you have few terms which is being summed, then you consider breaking it to this is what you have, G1 plus G2. Then you break it, so you consider first is where the non-homogeneous part is G1 and the second one is G2. Then you will combine the YP will be Y1 plus Y2. Okay? Where Y1 is the particular solution for non-homogeneous G1 and Y2 is particular solution for G2. Okay, so you simply combine them with sum, yeah, adding them. All right. So example 5 shows that you have 3 terms, exponential, sine t, and cos 2t, a product of exponential with the cos, yeah? So you see that you break it into 3 and then combine them. Okay? Example 6 basically showing that you will need to seek, you will need to consider, well, you will need to consider, this one it doesn't work, right? Instead of, yeah, you have the t coming in, yeah? You need to a product, or you multiply t with the sine cos. All right, so now we go to the final method for non-homogeneous second order DE. Okay, we're going to look at method of variation of parameters. So basically, when are you going to use this? Well, I would say MUC is easier in comparison to MVP. Variation of parameters is MVP. But you notice that MUC has some constraint where you will have product, the non-homogeneous part is of product is okay, sum is okay, but what if it is quotient? Yeah, quotient. Then you are not able to use MUC. Okay, so then if that is the case, then variation of parameters would be a better method to solve. Okay, the non-homogeneous differential equation. All right. So in other words, method of variation of parameters can also solve for product or sum for the non-homogeneous part. So basically, it is a more general method in comparison to MUC. Okay. All right. So let us look at an example where basically we learn the method through an example. So we look at this slide 38. So we start off with this equation. So we have y double prime plus 4y equal 3 cosecant t. So cosecant t is actually a quotient of sine and cos, right? What is cosecant?
1 over sine.
1 over sine, right? Cosecant is 1 over sine. So therefore it's a quotient. Okay, so therefore you are not able to use MUC. Okay, and then the homogeneous part. Very quickly, let's do the homogeneous part. Consider homogeneous equation. Y double prime plus 4y equals to 0. Assume solution is of the form y equals to e to the power of RT. So y prime is equals to RERT. So r squared is equals to minus 4, right? That means r is equals to plus or minus 2i.
Yeah.
Okay, so then the general solution for the homogeneous equation is y equals to
Cos t plus sin
cos 2t plus sine 2t.
Forgot the C1 and C2.
C1, C2. Okay. So, yeah, so this is what we have on the slide. And hence, based on this homogeneous solution, we can try out a particular solution to the non-homogeneous equation, where the solution, we try the solution to be y equals to, instead of C1, we have U1 it's a function of the independent variable multiplied by cos 2t plus U2. U2 is also a function of the independent variable t sine 2t. Okay, so based on the solution to the homogeneous equation, we try y equals to u1 cos t plus u2 sine t, and then sub into the ODE, where y prime is equals to u1 prime cos t plus u1 sine t.
Madam, it's 2T.
Aduh. 2t. Thank you. Cos 2t to sine t 2t. Correct?
Minus, right?
Oh, minus. Okay.
Plus.
This is for this.
Yes.
Then plus u2 prime sine 2t plus u2 or 2 cos 2t. That's u prime, y prime, and y double prime would be 4 terms. So we have u1 double prime cos 2t plus u1 prime minus sine 2t minus
2U prime
2u1 prime
sine 2T
sine 2t
minus
minus
4
u1 cos 2t. That's this plus u2 double prime
sine 2T
sine 2t
minus. Oh wait, that's plus.
plus, right?
Plus
u2 prime 2 cos 2t, and then
plus
plus
2U double prime
U prime
prime, right?
cos 2T
plus 2t
Minus
4
4u2
U
sine
sine
2t.
2t. Oh,
Correct, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then we substitute, right? Sub this into this. So we have, let's assume first u1 prime, u1 prime, where is it? u1 and, okay, this and this can be together. Okay. And then u2 prime cos 2t. This one and this is together, right?
Yeah. Yeah, okay.
That is minus 4 u1 prime. Correct?
Yeah, minus 4.
Okay. Then this one as well, right?
Yeah.
That is u2. Okay. So we have u1 double prime cos 2t. U1 double prime cos 2t, so minus 4u1 cos 2t. So this one. And then we have minus 4 u1 prime sine 2t, which is this. And then we have plus u2 double prime minus 4u2 sine 2t. This one. And then plus 4 u2 prime cos 2t. All that is equals to belum, ini baru y double prime plus 4y. 4y is this, so 4u1 cos 2t plus 4u2 cos sine 2t. Okay, so this is 4y, and all that is equals to 3 cosecant t. Okay. This can go, right? This and this can go. Yeah? This and this. So we are left with u1 double prime cos 2t. This one cannot. Okay, so basically this and this and this and this become 0. So then we have this and plus u2 double prime sine 2t plus 4u prime cos 2t equal 3 cosecant t. Okay. u1 prime cos 2t cos 2t plus u2 prime cos. This is sine and that is cos. Then we have right? Okay. That's y prime. That's y prime. This is y prime. Why are they showing y prime? Right. I already passed. This one is y double prime. Yeah, okay, substitute. Okay, we have already done this bit. This equation simplifies to. Okay, now simplifies to 2 u1 prime. Which is completely different. Plus u2 sine 2t, which is this. And this one. So this and this is missing. Wait, what happened? Okay. Okay, correct. What Ross saying?
Sorry, madam, tak sengaja.
Okay. Can you guys check whether I get the same? u1 prime. Why they still have this?
Where the two come
Where
from?
the two come from, though? Two? Still got two, right? No two, isn't it?
Right? Why different eh? Hiya. Right. This this one and this one. Oh, wow. It's gone. So if I were to continue, so u1 double prime
Yes.
plus 4u2 prime. Yeah, but I don't know because this one is u1 and this is u2. Sorry guys. Not too sure what happened.
I think the simplification is probably
Sorry?
the simplification.
Simplification.
No, lower a bit this time.
Wait, let's check the y prime. Is it the same as my y prime? 1, 2, 3, 4. 1, 2, 3, 4. Correct, right?
Just the average.
Yeah. So we have 2 u2 cos u1 prime cos 2t u2 prime sine 2t minus, yeah, correct?
Even y prime is the same, it's just the way it simplify is different from this.
Sorry?
The simplification is the way of simplification is different.
Yeah, but my y prime correct, right?
In y prime also correct.
Okay, so note that we need two equations to solve for you. The first equation is the differential equation.
Oh, because what? Because that u1 cos 2t plus u2 sin 2t equals to 0, right?
Oh.
So we can just substitute that from y prime. We can
This one,
Yes.
let's set a condition u1 prime cos 2t, which is this, and u2 prime, which is this, is equals to 0. Okay, so that means which one?
It's like what in
that from y prime
Oh.
the negative 2u1 sin 2t plus 2u cos 2t is equal to 0. So you're left with y prime equals to u prime cos 2t plus u2 prime sin 2t.
From here then.
Because since we know that assume that the homogeneous equation u1 cos 2t plus u2 sin 2t equals to 0.
So from my prime, you only left 2.
You mean this?
Yeah.
u1 plus 2t. u1 prime.
Where's u1 prime?
So you want y prime only left negative 2u1 pt.
No. The negative 2 and plus 2, that one can remove already.
This and this.
Yeah.
Yes.
Oh, okay.
Sorry, not this and this. This and this.
And
Right.
those are erased one. It equals
This
to 0.
and this is 0.
So you left negative 2.
Yeah.
Then,
Yeah, isn't it?
I mean 2u2 cos 2t.
Equals to,
okay.
yeah, that's right. Yeah.
Sorry?
Yeah,
it's
just like
correct.
that.
So
Yeah,
that
that.
one is equal to 0. So we left only 2 in y prime.
Yeah. So what I mean is this one tak perlu,
Yeah.
Yeah,
right?
yeah.
Yeah. Element. That's okay. So we reached to here, and we are saying that require. Nah, ini kena ingat ah. So u1 prime cos 2t plus u2 prime sin 2t equals 0.
Yes.
So which means this and this gone. We are left only with this,
Yes.
which means so ini tak ada. Ini tak ada, right?
First row is gone.
That's right.
And third row.
And third row gone. So we are left only this, and we substitute. So we have. So we don't have u1 double prime.
Yeah.
Kan? So we have only this. Okay, let me padamlah dulu. Sorry guys. Okay, so this requirement is very important. So we have we sambung lah sign. We sambung straight away. Okay. Sin 2t minus 4u1 cos 2t
Plus 2.
plus 2 u2 prime
Plus 2.
cos 2t minus 4u2 sin 2t plus 4u1 cos 2t plus 4u2 sin 2t equal 3 cosecant t. Okay, so from here, cos 2t,
So we apply the same.
so this and this goes. We still manage to get rid of this and this jadi kosong, right? Betul tak, my mata? Correct, right?
I thought it's u1 prime.
Huh?
u1 prime cos 2t plus u2 prime cos 2 sine 2t is 0.
Which one?
Where?
The u1 prime one.
U1.
Prime plus u2 prime sine 2t equals to 0.
This and this.
Boleh zero lagi kah?
Why 0 lagi?
Or because of the like require something, then the requirement that we use.
This one.
Yeah.
Apply back again.
Then 0, everything 0.
Yeah.
Because this and this 0.
But then again,
Right? This
zero.
and this 0. So if you said this and this, huh?
Is it everything zero enough?
Saya pun sudah gila already.
That's
Right?
like
Beauty of man.
Oh my god.
Correct ka our y double prime?
It's correct. It's correct.
Correct. And substituting is to okay, so they don't get rid of that. So which means this and this goes. This and this.
Okay.
This and this goes.
This is that goal.
Then we are left with minus
2u
2u1 prime sine 2t
plus 2
plus 2u2 prime cos 2t equal 3 cosecant t. So we have first equation. This is our first equation. This is our second equation. That's what they are saying. Okay, so this is first equation, the requirement just now, and this is second equation. Then you can solve for u1 prime. Betul lah, this one is plus ba? This one is minus.
oh.
Yeah.
Oh yeah.
Okay,
Oh.
so and u1 prime, it's u1 prime multiplied by cos. This one is u1 prime multiplied by sine. You see that?
Rabun kah?
Okay.
Everything.
So
is the
now
same.
we have two equations. This, the requirement we set, and the one that we end up with, second equation. Then we can solve for u1 prime and u2 prime. It's a simultaneous equation. So how do we do that?
Are we really going to do this?
Let's see. Do they show it here? Yeah,
Oh,
that's what I thought. This one, from this equation, we have u1 prime equal to minus prime sine 2t over cos 2t. Ini masuk inside here. So I call this one star. Sub 1 star into 2. So we have minus 2. Oh my god. So plus u2 prime sine 2t over cos 2t multiplied by sine 2t. plus 2u2 prime cos 2t equal 3 cosecant t. So now we take u2 prime correct, right?
Okay. I can see.
u2 prime equal
Just the minus from U1.
multiplied by
Oh.
sine square 2t
Okay.
plus cos square 2t equal now it's secant. Yeah. Cos over sine. This is cos over sine. Cos over sine is secant, right?
Wait.
No, bukan. Cos over cotangent. Cotangent, right?
Yeah.
Because your cos goes here now. Then this is 1.
Why?
Tahu tak?
I
Why?
Tak sama lagi?
It left cosine and then the 2 pun.
Substituting, sudah substitute. Oh, ini because they put u2 prime. Huh?
easier.
They put u2 prime. I put u1 prime.
Okay. See that? So what's the value of
So let's see. Let us see. Then my u2 prime is equals to 3/2 cotangent t. Then this is betul lah. Cos over sine is cotangent, right?
Wait, what?
Cos over sine is cotangent. Yeah.
Cos over sine, yeah, potential.
But why they have a u1 prime there? Okay, Tapa. So sub to 1 prime, a1 star. Then I have u1 prime equals
3 negative 3.
minus sine. This is tangent. Sine over cos is tangent, right?
Yes.
So 3/2 cotangent t, that is my u2 prime, and then times tangent. This is sudah 3.
That is tangent 2t of them.
2t. Sama lah. This one also right.
Yes, then cotangent t.
Thank you, Patrick. No wonder. Okay. That's why. So this is cosecant. This is cos 2t over sine t, not sine 2t. Okay. Betul?
Yes.
Sopan nampak. Sine t. Yes.
Betul? macam lah, yeah. So then this is U2 prime 3/2 cos 2t over sine t.
Cos 2t over sine t.
Tak sama. Dia tolak.
Cos 2t is multiplied.
Kenapa tolak?
How did they?
Sine square, betul kan? Sine square. And then cos over cos, cos square lah. Ada salah tak? Okay. Yeah. Substitute that into this.
That's 2t.
Ow! Minus.
Huh?
Yes.
No?
No, negative, negative, and positive.
Negative, negative, positive. Betul. Sine, betul.
Okay, so
Cosecant is 1 over sine, right? Yeah, the minus 3 sine t. Don't know where that comes from.
Cosecant is 1 over sine. Cosecant is 1 over sine.
So
Yeah,
that's why
so
this
yeah.
sine
Yeah, that's why the
is
sine
there.
is there.
what's cos over sine?
Cos of the sine is cotangent.
But the one is 2t, one is t.
Yeah.
Oh.
Betul? Minus
Let it go of Mercury.
sine 2t over cos 2t.
Let's pray for the gods.
U2 prime. So this is 3 over 2 cos 2t over sine.
What is that?
This is 2 sine t cos t. This sine 2t is 2 sine t cos t, right?
Yeah.
Over sine t.
The 3 cos t. Oh, betul. You want
Betul!
then what is here?
Betul lah saya.
It's just the trigonometry.
It's just trigonometric because this one they left it cosecant.
Okay.
No problem.
So
Cos 2t is equals to what?
2 sin A cos A. Why put sin A lah? 2
Cos square t minus sine square t.
nice.
Right? Anyway, but it's the same. Basically, this U1 prime.
Yes.
That's the same. This, I'm sure if you were to break this is 1 over cos, 1 over sine. Yeah, I'm sure it's the same.
Okay.
Okay. And now we are not done yet because this is prime. So which means you need to integrate
Yes.
to find what is U2 and U prime.
U2.
U1. U1. Okay. So from here, say you can start from here. So you have integrate this, you get u1 is equals to minus 3 cos t integration dt. So that gives us u1 equals to
minus 3
sine t
plus c
plus a constant, yeah. Okay. So ini you punya u1, and you can do the same for u2. Okay. So that is shown on slide 42. You need to integrate u1 and u1 prime and u2 prime to get u1 and u2. And then you substitute back into your original tryout, which is this. Okay. You substitute back what is your u1 and what is your u2 inside here. This one is the particular solution, and yc is the homogeneous solution. And simplify to get the solution, which is very long. Okay. So on summary, what did we do? So we have a fundamental set of solution for the homogeneous equation, and then the non-homogeneous equation. You will say that it is u1 times y1 plus u2 times y2. Okay, so the one at the top. And the requirement in order for us to get or to obtain u1 and u2, because that's our aim, to find out what are u1 and u2. We need u1 prime times y1 plus u2 prime times y2 to be equals to 0. So this one is a requirement, and then when you substitute that into the ODE, you will end up with this, using this. Okay, so with these two equations, you solve for u1 prime and u2 prime, and apparently if you were to leave that on, you'll get this formula where u1 prime is equals to minus y2 multiplied by gt over the Wronskian, and y2 prime equals to y1 g over the Wronskian. So because for this, the one that we did just now, it is for a specific ODE. The one shown on the summary, it is for general, general ODE, yeah. So we still have our PQ there as the coefficient of y1, y prime and y. So apparently these are the formula. Okay. Procedure is the same. It's simply saying that we start off, this is our general ODE. Okay, we say we try this as a solution. Particular solution is this. according to MVP, okay, method of variation of parameters, the particular solution has this form: y equals to u1 y1 plus u2 y2, where y1 and y2 are fundamental the set of solutions. Okay, then substitute to the ODE, where y prime equals to u1 prime y1 plus u1 y1 prime plus u2 prime y2 plus u2 y2 prime. Betul? Okay. Require which one? Y1 prime. Is it the Y1 prime? Yeah. Y1 plus U2 prime Y2 is equals to 0. Then Y prime is equals to, so this, and this is equals to 0. So we end up with the then y double prime is equals to u1 prime y1 prime plus u1 y1 double prime plus u2 prime y2 prime plus u2 y2 double prime. Okay, so now I'm doing it in general. So when we substitute in there, we have y1 prime y1 prime plus u1 y1 double prime plus u2 prime y2 prime plus u2 y2 double prime plus p y prime, which is u1 y prime plus u2 y2 prime plus q u1 y1 plus u2 y2 equal g. Okay, now I collect all these first. U1, so I have y1 double prime, that's this, and then I have plus py prime, which is this, and then plus q y1, which is this. Then I have plus u2, u2 like that, y2 double prime, that's this. Then plus py2 prime, this one, plus q y2, that's this. Okay. Then the remaining, we have y1 prime, u1 prime, y1 prime, that's this one, plus u2 prime, y2 prime, that's this, and that's it, equal G. So you notice the one in the square bracket, this is the ODE. And we know that y1 is a solution, okay? And solution to the homogeneous, yeah? Homogeneous. So then this is 0. Okay? Same thing with this. So this is 0. So you end up with only this. Okay? So hence you will have two equations. First, I already used one, so I used 2. And the other one is this. So you can solve for 2 and 3 simultaneous equations where u1 prime and u2 prime can be solved. Right? Wow, no break. Apa? You want me to proceed? Show until we get this? Basically, that's what you're doing, yeah? So when you do this, you should get that. So let's do that very quickly. No response from here, so I just proceed. Okay, so from 2, we have u1 prime is equal to minus u2 prime y2 over y1. No? Okay. Sub to 3. Sub to 3, we have minus u2 prime y2 over y1 multiplied by y1 prime plus u2 prime y2 prime equal G. Yes? Then u2 prime, we have y2 prime y1 because correct y1 right minus
y2 y1 prime
y2 y1 prime equal
G
G y1, yeah? Nampak? So therefore,
U2
U2 prime is equals to G Y1 over Y2 prime Y1 minus Y2 Y1 prime. And what is that?
The determinant, the Wronskian.
That's the, no? Balik, right?
Correct. Yeah,
What is Wronskian?
y1 times y2 prime minus y2 y1 prime.
Recall Wronskian is equals to Wronskian of y1 and y2 is equals to y1 prime y2 minus y2 prime y1. Correct?
No. It's y1 y2 prime minus y2 y1 prime.
Oh, yeah.
Y1,
Y2 ah?
No,
Y2.
no, y1 y2 prime.
yeah, it's Y2 and Y1.
Y2, right?
y1, then it's y1 y2.
Betul?
Oh,
Okay. So therefore, U2 prime equals to GY1 over W. Correct?
Yes.
yeah.
Okay. Then this substitute back here, then you should get you have Y1 prime equal minus
G.
U2 prime Y2 Y sorry Y2 over Y1 multiplied by
GY1
GY1 over W. Then this gone, so you have minus Y2 over G over W. Okay, so basically you should be able to prove this, right? This.
Yeah. Yeah.
And then because it's du dt, hence you can get u by integrating.
Okay.
So kalau soalan say show that this and this, that's the way.
So only show need to do like this lah.
Yeah.
Okay.
Yeah. All right. Okay, and then this theorem says what? If the functions p, q, and g are all continuous, and y1, y2 are solutions, then a particular solution of, okay, so it's just saying that that's the particular solution. Okay, the particular solution is y is equals to u1 y1 plus u2 y2. This is the particular solution. Okay, that's what theorem says, and we are done. Okay, so that is what MVP is, the method of variation of parameters. And you have one requirement which I have already wrapped off.
Variation parameters.
I wrapped off just now. I hope you took note, yeah? What is the requirement? The requirement is u1 prime y1 plus u2 prime y2 is equals to 0. That's the requirement. Okay, so there's only one that you need to remember, which is that on slide 44, yeah, the first equation, y1 prime multiplied by y1 plus u2 prime multiplied by y2 is equals to 0. And then when you substitute, you should be able to get the second equation. All right. Okay. So for second order differential equation, we have looked at characteristic equation. We started off with homogeneous second order differential equation, and we can find the characteristic equation when the coefficients of y double prime, y prime, and y, they are all constants. Yeah, when they are constants, then you can use characteristic equation, or you can find the characteristic equation and then find the roots of the characteristic equation. Depending on the roots of the characteristic equation, you will be able to find the general solution of the homogeneous equation. All right. So then you have learned about method of reduction of order, whereby if you know one solution to the differential equation, then you can find a second solution where you multiply a function v with the first solution. Then your aim is to find that v. Okay. And then we move on to non-homogeneous second order differential equation, whereby the solution to the differential equation is the summation of the homogeneous solution plus and the particular solution. Okay, particular solution is where you consider the non-homogeneous equation. And to find the particular solution, you have learned the method of undetermined coefficients, the most simplest one. If your non-homogeneous part, which is G, they are polynomial, exponential, sine or cos, and also product of them or sum of them. Okay, but it also does not work when YH is in the form of G. So if you notice that the homogeneous part is also the same as the non-homogeneous part, which is G, then you will need to see that it doesn't work. Yeah, you need to multiply it with another function. So if that happens, and also if the G is a quotient, then you might as well use the variation of parameters. Okay, so that is how you decide what method to use. Okay, it doesn't tell you what method to use. You need to look at the differential equation to decide which method to use. Okay, so that's about it. That ends all the method on how to solve second order differential equation, homogeneous or non-homogeneous. Now, what do you think of that? Remember, we have so we can find the solution of this where A, B, and C are constants. The question now is, what if they are not constant?
Meaning they're like function of something.
Function of time, a function of the independent variable. Because if they are constant, then you are able to find the homogeneous solution. Right? The homogeneous solution, you get this, right?
Yeah.
can. This is constants, and y1, y2 are the you can use the characteristic equation lah, because these are constants. So when they are not constant, then you have another method. So that brings us to the next LU.
Series.
Also, that is series, huh?
So next LU
It's like a movie.
method of series solutions.
Oh, it's still under second.
Still
ODE,
under
yeah.
second one.
Yeah.
Oh.
But the method that you learn there, you can even be applied for higher order.
Meaning that.
So in third order is still.
Yeah, you can
Just
use
learn
series
the-
solutions.
So we just use series
Yeah.
for the.
Yeah, you can. Okay, so that's it for today. I'll see you tomorrow. I hope tomorrow, right? Today is Thursday, Wednesday. Yeah.
Yeah.
Tomorrow is the
Tomorrow is 3 o'clock. Do you want to do it online?
Online.
Online.
I think online.
since
Online, aha.
Yeah.
We'll see how. I hope I'm okay with that pen.
are you just thinking about it?
Yeah, tomorrow. So tomorrow is tutorial. So I hope you guys go through tutorial 3.
Yeah. It's suffering.
Okay.
Really?
Suffering. Okay, so please make
You're
sure that
suffering.
you prepare which question to go through.
Yeah.
If possible, you let me know earlier so that I myself can prepare myself. Can I have QR? Alright, boleh. Boleh saja.
Tutorials.
You just send the video. Okay, just keep the questions.
Mana pergi?
Just send the video.
Share.
I only do like one question. For
Yeah,
each
we
month.
do have.
Okay, those who haven't taken the attendance, please scan. So again, I repeat, tomorrow we'll do it online.
How about PBL updates?
Oh yeah, TBL observation week
Next week lah when you are back.
next week. Public holiday dua. Oh, Wednesday kah?
Wednesday.
Wednesday.
Yeah.
Is
Online?
it next Wednesday or
Next Wednesday?
Wednesday after?
Wait.
Next
Next Wednesday is test, right?
Huh?
What?
Huh?
I did say right.
Wait.
Third, right? I did say third.
Oh yeah.
Third May.
Of May. Yeah.
Next Wednesday.
It's first order, right?
Next week is May already.
Yeah, next week is May already.
next,
Oh no.
next week is May already.
Oh, Oh, yeah.
26.
So PBL boleh tangguh ke?
Wait.
You know, there's
So
only
first
30 days.
is cuti, Monday,
Yeah.
and then we have test on Wednesday.
First order, right?
Huh?
Until
What is the
chapter?
syllabus now?
It's only
No,
first
it's
order, right?
I'll inform right after this. I need to check. I already prepared.
Oh,
I forgot.
I hope it's
that is actually
Then Thursday.
Thursday.
So Thursday.
Thursday also
This
public.
Thursday or next Thursday?
Thursday also public.
Yeah, next Thursday is Waisak.
Oh
Monday.
yeah lah.
Monday.
Oh
Monday.
yeah. So that means we can only do the observation
next week.
the week after that.
So after mid-sem.
Belum break, right?
It's
When is
mid-sem
break?
Break is second week of May.
Yeah.
Yeah,
So it
already
is
break.
mid-sem break.
Yeah, it's already break.
So right after.
Yeah.
After
After mid-sem break.
mid-sem break, then after mid-sem break, Monday we don't have right.
Huh? Yeah.
No,
After
we
mid-sem
have
break, the
nothing on
Monday
Monday.
is public
Sorry,
holiday.
we have nothing on Monday, right?
Yeah. After the mid-sem lah. After mid-sem
After
break.
mid-sem, everything is normal already, right?
Okay.
Yeah, so far.
So then we have the observation on Monday lah,
After
You
mid-sem.
mean
after the break.
third week of May?
Yeah.
Then Monday, as usual, Monday and Thursday.
So after mid-sem.
No, we still have Wednesday because we miss out few.
So after mid-sem, we still have Monday, Wednesday, and Thursday
Yeah.
class.
Wait, so after mid-sem, Monday will be the observation, kan? And then also be normal classes.
No, we have 2 hours. We can have. It depends on the question that you are going to give me. So because observation is where you ask me question rather than
And
the other way
then,
around.
and then next Monday will be presentation already.
Yeah.
So after
End of
first,
After
week for the 4th week of May lah.
is
The
the
Monday of the 4th week of May
after the observation
would be your presentation.
Yep.
Oh, okay.
It's both Mondays.
Oh,
So it's
Monday.
all the Mondays.
Oh, Monday.
Yeah. So then that's the time I also introduce series solution, right?
Yeah.
Yeah. On the 3rd week, not the 4th week.
That week of
3rd week Monday observation. It depends on your question. If a lot or not, then we'll use the whole 2 hours. If by 1 hour we can finish, then I can straight away start with series solution on that Monday, and then on Wednesday. Okay. Yeah. Because we after that learning unit, we have another 2 learning unit to finish. Yeah. So we have 3 more learning unit actually. Yeah. Series solution, system of
system of
and then PDE.
what is system? What is
Wait.
system?
System means that we solve more than one equation.
Oh, so just like normal.
So combine everything we've learned so far and then make it multiple equations.
There's a method to use lah.
More methods.
Yes, more methods.
More methods to prove.
Yes, yes, yes. Okay, boleh? So I see you tomorrow. All prepared your tutorial ya. So kalau boleh, you ask me question. Which question in the MS team?
Next week is test, right?
Yeah.
The test is written or
It's online.
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 Last time
Yeah,
we
but
did it
online,
right?
but
Online,
online
like-
you need to
You need to snap.
you need to
Snap.
snapshot our
Snap.
So where's that?
There's how many questions?
Nanti kita bincang
Bisa.
in MS team.
Ada-
Tomorrow. I'll let you know tomorrow.
Yeah.
She just announced instead of bincang.
Alright?
Better announce. First and second order.
That's exactly what.
Yeah, it's including second order.
Huh? Both non-homo and non-homo both.
That one I forgot. Yeah.
A simple one.
Macam, if I'm not mistaken, 4 question long, 4 long,
But the answer,
which I estimate 1 question 30 minutes. So I give you 2 hours to do all of it.
I don't think I can do all that.
4 questions, 1 question 30 minutes each.
In first order, I need 15 minutes.
Yeah lah, so that's why I said 2 hours.
2 hours.
So I open and close 2 hours.
Also 2 hours.
Yeah, 2 hours.
2 hours.
So it's Wednesday.
Wednesday 9 to 11
AM.
online. AM lah.
PM.
Okay? Any question? Any more question? 27 students only. Okay lah. Alright, so see you online tomorrow.
Okay.
Thank you. Sorry, no break because we start very late.
Nice.
Apa yang after mid-sem break?
I
It
think
was the-
she meant the PBL observation week.
Observation. Yeah, we already say it's after, right?
Yeah.
Yeah. The test cannot lie, yeah?
Yeah, next week.
Yeah, suddenly May. Oh.
Alright. Thank you for coming.
Thank you, Nada.
Thank you,
Thank you.